Okay, this is just a brief intro to a analog lab that I'm going to show you during class period, and it's using a pressure sensor that's for air pressure, or you could say maybe for water pressure or any kind of pressure or hydraulic pressure. And it has a range of 0 to 145 psi sensing range, which equates to 4 to 20 milliamp on the electrical signal that this pressure transmitter produces. So at 0 pounds you get 4 milliamps. At 145 psi you get 20 milliamps leaving the sensor going to the PLC. So it leaves here and it goes here to an analog card, analog input. We're going to go over in class, and then we go through a PID loop in the program. A PID instruction I've set up in the program that I've got set up for a set point of 35 psi, and I'm using a foot pump here to generate pressure to a little accumulator tank. And right now I've got pressure built up in this thing, and I have the pressure line here connected to the sensor. Then the sensor is going to the PLC input, and then that's the input card for analog, output analog card here. And I've got a analog cable here, 4 to 20 milliamp, with a current clamp on it checking the milliamps. This meter here shows you the milliamps, the DC milliamps that's being sent to the VFD. This is the VFD we're running. This is the 3-phase motor that we're running. So as I go down in relief pressure, right now the PID is actually satisfied right now. My sensor is sitting at 35 psi. And right now the output, the output on the bottom line says 0. So the output of the PID is 0%, which is 4 milliamps on the signal line, which is 0 hertz on the drive. And you see that the shaft is not turning. Now, so as I go down here and crack open a relief valve, when I crack it open and bleed air off of that accumulator, you're going to see the PID line where it says your control your process variable is the sensor. I'm going to bleed some air, and you watch it start to drop. So now as it starts to drop, and then I close that relief valve, you see that the VFD came on, the motor's turning. Hold on, my meter went to sleep here. Hold on, let's get the clamp back off. Reset the meter. Okay, had to get the clamp meter, had to remove it because the meter went to sleep. So right now we're sitting at 20 milliamps, and the 20 milliamps equates to 60 hertz on the drive. 20 milliamps equals 60 hertz on the drive. Now just as soon as I increase some pressure, right now the PID sees 32 pounds of air pressure. I'm going to take the foot pump and increase pressure. So as I increase pressure on this foot pump here manually, I'm running the foot pump with one hand, and now if you look, The output of the analog output is now down at 16 milliamps, and the drive is down at 43 hertz. So we're down at 15 milliamps analog signal going to the drive at 35 hertz, because we're just below the set point of 35 pounds on the pressure. So the VFD has slowed way down. You can see that. It's slowed way down. I know it's hard to see you can see all that now. So at 9 milliamps output of the analog card going to the drive, you're just down at a crawl right now of the motor. The motor would be running a pump, for instance. Could be running a pump. You see, it's ramping down real slow. So at 6 milliamps, you got 8 hertz on the motor, and it's just crawling. It's barely crawling, because we're sitting close to the set point right now. If we go back to the PID loop, we're sitting here. We're actually at the set point, and now the output went to 0. So the output of PID went to 0. The output of the analog card went to 4 milliamps, which equals 0. Equals 0 on speed, because the range is 4 to 20 milliamps. 4 equals 0 on speed. 20 milliamps would equal full speed on the drive. See, we're at 0 hertz now. 4 milliamps going to the drive gives you 0 hertz, and the motor's not turning. Now, if I go back down to that relief valve and I open it up, as I open it up, you're going to see the current increase gradually. So I'm starting to open it now a little bit. And as you see that, as it starts to build up, now you see the drive is speeding up. You're at a full 20 milliamps right now, and you're at 60 hertz. Let's see. 20 milliamps equals 60 hertz as far as speed. That's 100% speed on the drive, and that drive is going wide open there. And you're getting full signal from the PLC at 20 milliamps, because your process variable is below 35 pounds. It's at 33 pounds. So the PLC is telling the VFD go wide open and give me some more pressure. And it's gone to 100% because the pressure source, which would be the pump, is not working, which is me. So I've got to start pumping again. So I got to start pumping this hand pump again. And as I do that, you watch the loop. So it's slowing down very gradually now. We're right at the set point, and so we're sitting here now on the drive with 17 milliamps at 50 hertz. So it's modulated the speed back. The PLC is giving 17 milliamps. The drive is doing 49 hertz, and you can see that it has slowed down considerably. Now, if I pump it some more, pump the pressure sensor some more, you're going to see this go down. So I'm pumping the foot pump now. The PID, we're sitting here at 34 pounds of pressure. We need 35, so it's giving you 77% output, or 78%, which is less than 20 milliamps. You're sitting at 48 hertz now. It's 16 milliamp signal going into the drive. So you see how it's modulating back. The more I pump the foot pump, as soon as I get to 35 pounds, you see the output of the PID will go to 0. So if I pump it quickly and go ahead and get to 35 pounds,